Hey kids, we're back again. This is grade 5, module 1, lesson 1. We are just getting started with this year. Again, I'm Mrs. Setness. If you want to subscribe to my channel, click subscribe. It is probably a little red button, looks like this. That's how you spell it. Be a subscriber. This is a great time to do it. Beginning of 5th grade, if you've got a 5th grader and you're trying to figure out this math, this Eureka math, I have many lessons on this math program for 5th graders, and I like to think that it's helpful. A lot of people have said they are very helpful. So a couple things about using this book. The objective that I usually try to include in the lesson is usually written, or is always at the bottom of the page in very tiny letters, but you really kind of have to think about what it is that you're trying to do so that you will come away with something important. So that's what we're doing today. Lesson 1, the objective is to reason concretely and pictorially, so like you can think about it and explain it and draw a picture. Using place value, I often will abbreviate with PV, place value understanding, to relate adjacent, there's that word, I just introduced it in the last video lesson on our place value system. To relate, show how they're related. Adjacent, which means right next to. Base 10 units. So relate all the place value positions together from millions to thousandths. That would be fractional units, decimal fractions. Okay, so make sure you have your place value chart handy, the one you made in the previous video. I'm not going to spend a lot of time on that because we already did it on the other video, but keep that chart handy. And here is the big idea. This is basically for lessons 1 and 2, but I wanted to start off with these notes. Each time you multiply a number by 10, you will move all the digits in that same order, one place to the left. Everything just goes shift. When you multiply by 100, you're going to move all the digits in that same order, 2 places to the left. Shift, shift. When you multiply by 1,000, you're going to move all the digits 3 places to the left. 1, 2, 3. Now, this doesn't have a chart right here, but I'm going to show you how. 345 times 10 would then shift all the 3, 4, 5 together, 1 place value position over. This was in the hundreds place. When you shift it 1 time, it's going to be in the thousandths place. So when you have thousands, it's going to be 3,450. Notice there are no zeros inserted in between. You don't mix up the numbers, the digits. Okay, if I have a number that has a decimal fraction, this is what's called a decimal fraction. It's just kind of a saying, a decimal number. 6.87 or 6 and 87 hundredths times 100. So you have to look at the place value chart, do the shifting 2 times. So notice that I have the little 1, 2. And so when you end up with the 6 going from the ones to the tens and hundreds, you end up with 687 because the 8 goes to the ones, then the tens, the 7 goes to the tenths, and then the ones. You end up not having to put a decimal here because you just have a number with ones as your final. If I take 429 and 5/10 times 1,000, it's going to go 3 shifted positions. The 4 goes 1, 2, 3. The 2 goes 1, 2, 3. The 9 goes 1, 2, 3. And the 5 goes 1, 2, 3. And as you see all these little hops and the place value chart, you end up with 429,500. So those are some samples. You make sure you write these down in your notebook. Pause the video until that is done. Now, next thing, we're going to get into the book and we're going to finish this lesson. In the book, there is a fancy place value chart, but nothing is labeled. So you need to take a couple minutes. It's nice if you're consistent, but sometimes you'll just be in a big hurry. So I like to say, hey, let's take a minute and show me that you understand what the words are. So I'll say, write the whole thing out. Ones, tens, hundreds, or to the other side, tenths. Remember, there's no oneths. This number is going to be 1/10 of ones. So that's why we call it tenths. It's already been broken into 10 little tiny pieces. This is 100. Try not to spit on people when you say that. And this is thousandths. Don't forget, it's THS for all the fractional units, the decimal fractions. Another way people will do it because they run out of time is they'll do 1/10, 1/100th, 1/1000th. See how much faster that is? So show that you understand what the words are. You can put thousand over here, no THS. No THS over here. So this one is done for you. What are they doing? Look at the top. Look at the top number. This is 3 and 452 thousandths. That's how you read that, okay? They don't start with anything light in this program. It goes right into the heavy stuff. So multiply this number by 10. They show you the shift, and you end up with 34 and 52 hundredths. Okay, now you're going to do it. So ones, tens, hundreds, thousands, tenths, hundredths, thousandths. Label it. Do it right now. Okay, on the top line, write what you are working with. 3.452. Now, you get to multiply by 100. Each 0 means a shift of a full place value position. It's going to be 100 times greater, so 10 times 10. So it's going to be 2 shifts, 2 shifts, 2 and 2. So you'll end up with 345.2. And you put your answer on the line if you'd like. 345 and 2 tenths. Okay, got another one. Let's label it. Ones, tens, hundreds, thousands. Tenths, hundredths, thousandths. Okay, fractional units. 3.452. Same, 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 but changing it in different ways. First one was a hop of 1. Second one was a hop of 2. Look at the pattern. It's a hop of 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. If I have nothing over here, okay, when I write this, it would simply be 3,452. You don't have to put the decimal or a 0 afterwards. Part D, explain how and why the value of the 5 changed in A, B, and C. Stop being blurry. Stop being blurry. Oh, thank you so much. Okay, so when you have numbers being multiplied by 10, 100, or 1,000, you're proving that each time you move it, it's becoming greater by that number. So by 10, by 100, by 1,000. The 5, which started in the hundredths place, changed by 10, changed by 100, changed by 1,000. Okay, so let's write that out. You can basically copy this. You can pause. When multiplying by 10, 100, or 1,000, shift the digits to the left so they will get bigger. Now, when they get bigger, they're not getting bigger in size, but they have greater value, if that's the way you want to say it, or if that makes more sense to you. So if I have 345 times 10, it becomes 3,450. But when I multiply by 100, again, 2 shifts. So this is the general explanation. The 5 becomes 10 times greater. Each place value position it moves to the left. Specify. Because if you're saying 10 times greater, you've got to talk about to the left. Okay, turn the page. If you need to go back or pause, do that anytime you need to. Use the place value chart and arrows to show how the value of each digit changes. Look, again, they're not going to hold any punches. They are just going to jump right into division. 345 divided by 10 equals what? So if this is ones and tens and hundreds and thousands, and this is tenths, hundredths, thousandths, notice what's happening this time. We've talked about numbers increasing in value each time you multiply by 10, multiply by 100, multiply by 1,000. This page is simply the opposite. It's exactly the opposite. Multiplication and division are inverse operations. That means they do the opposite. Write that down. Okay, they do the opposite of each other. So whatever multiplication does to make a number bigger when we're talking about whole numbers, division undoes it. It makes it smaller. So when I have 345 and I divide by 10, I'm really taking 1/10 of that number. So we shift to the right. In the same way that we multiplied and went to the left, we shift to the right with division. Watch your signs on these activities. 345, again, ones, tens, hundreds, tenths, hundredths. So if I have 345 to start and I need to shift it 2 place value positions, I'm going to end up with 3.45 because it's a 2 position shift. 2 positions. This is not a position here, even though they have this little column. Basically, in the future, when I write the charts, I put the decimal on a line so that kids aren't counting this as a position. Okay? Again, 345, ones, tens, hundreds, and then if you go off this way, 1/10, 1/100th, 1/1000th this time, because guess what? We have to divide, therefore move it to the right 3 positions. 3 is going to move over 3 times. 1, 2, 3. And all these numbers stick together. You don't change the 3, 4, 5. You don't insert zeros. It's going to be 3, 4, 5 sticking next to each other. The only thing that you might want to do, other than write your answer up here, the only thing that you might want to do, and it's going to be very common in this book and pretty much everywhere, when there is only a decimal fraction, they will put a 0 in the ones place to show that, hey, there is no whole number here attached with this decimal fraction. In the same way you wrote the answer explaining how the value of the 4 or just one number changes in all these quotients, same thing. When dividing by 10, 100, or 1,000, shift the digits to the right so they will get smaller or have less value. Each 0 is going to be a shift. 1 0, 1 shift. 2 zeros, 2 shifts. That's how it works. Very easy concept. It's confusing the way it's kind of laid out, but the big idea is count the zeros and make the same number of shifts. Okay? So the 4 changed because when dividing by 10, 100, or 1,000, shift it one time, 2 times, 3 times, okay, for each 0. So that's the big idea there. Let's move on into the problems that have words, the word problems. A manufacturer made 7,234 boxes of coffee stirrers. Each box contains 1,000 stirrers. When you see the word each, please think about it being 1. but we can't just take one box alone. So it's going to be like each and every box. So the word each means one. You're going to see each in our book so many times. Please understand that it means one box. One box contains 1,000 stirrers. How many stirrers did they make? So we're going to take our 7,234 boxes, okay? And if I have 7,000, what would that look like? Well, I'd have one here, and I'd have one here, and I'd have one here, but that's a lot to count up to. So if I have one box and it has 1,000, an easier way of doing it would be to take the total number of boxes and multiply by how many are in one box to find the total. So if I have 7,234 and I have to shift the digits 3 places, okay, if you need to make a place value chart, you can always just draw the lines between the numbers and then show and count how many or what the place value position name is that it's going to. So I have to go 3 positions to the left, 1, 2, 3. If it's already in the thousands, it's going to be 10,000, 100,000, million. 7, 2, 3, 4, but this is in the millions. And then label it. So the statement and the thinking is shown right here, but the statement would be like, if each box contains 1,000 stirrers, then you multiply that by the number of boxes. Okay, I hope that makes sense. Use a place value chart or draw one whenever you need it. Keep your notes handy. Again, you've already made a place value chart, so pull it over, put it down, fill in blanks as you need to. Next one. A student used his place value chart to show a number. This one's tricky. After the teacher instructed him to multiply his number by 10, the chart showed 3,200 and 4/10. You don't draw that in here. We're not putting the answer in the box. You're going to draw a picture or put in the box of what the place value chart looked like at first. So before the operation was done. So if you want to think about it, the lights went out. Welcome back to school. They always go out on my videos because I'm not moving around too much. Anyway, welcome back. Woohoo! You should check out some of the ones from last year. They are very entertaining, let's just say. So anyway, we have a number, mystery number. This is what we want to put in here. And the teacher said to multiply the mystery number by 10. The answer to that is 3,204/10 or 3,204/10. So basically, this is 10 times greater than what we had at first. So what I need in this chart is something that's 10 times less than this, or what I would say mathematically correctly is 1/10 of this value. So what number is 1/10 that? Well, take 3,204/10 and you would do the inverse operation. You would divide it by 10 to get the answer. So what would it be? If everything shifts to the right because of division, it's going to be 3/20 and 4/100ths. And go ahead and label your place value positions in the top. Now, if you want to explain, and you need to explain how you decided what to draw in your place value chart, include your reasoning. We wrote it here, and it says use words, pictures, or numbers. We kind of use numbers, but I'll write the explanation. You're going to do the opposite to basically back up to what you had before So it was smaller, and then it was times 10, and then you had the bigger answer, and that was where you got the 3,200. Okay, so I hope you're making the connection between the multiplying, and that gives you something bigger, and dividing, and that gives you something smaller. So if I multiplied and got something bigger, then do the opposite, divide and get something smaller. Okay, and the last one. A microscope has a setting that magnifies an object so that it appears 100 times as large when viewed through the eyepiece. If a tiny insect is this big, 95 thousandths of 1 centimeter long, how long will the insect appear in centimeters through the microscope? And then you have to explain how you know. So if it is 95 thousandths, but I'm going to look through the microscope, it's going to look 100 times as large. So what happens to this number? Again, if you multiply by 100, we're going to have a shift of how many? 2. And which way is it going to go? To the left. Okay, so that's going to be a 1, 2, which ends up giving you 9 5/10 centimeters. So it's going to look that large. So it would look 100 times larger than it looked at first. Okay, so that is really what lesson 1 is all about. It's place value. We're going to talk about place value almost every single day this year. Very, very important. Hope you enjoyed the video. Come back for the next ones, and we're going to talk about a lot of math. Have a great day. Bye.